second lesson in Unit 8, and this is another look at particle motion. So we've looked at it before, so we're just going to review some things and then kind of tie some more things together. So the type of particle motions problems that we have been dealing with and are going to deal with for a little bit longer is moving on a straight line. So horizontal or vertical movement on a straight line. We're going to talk about, so normally we just talked about going from velocity to acceleration, or now we're going to go back the other direction and so on. Okay, and then later for the BC only topics, we will do parametric equations that will allow us to look at a particle moving on a curve. So it does not have to be just on a straight line. But these concepts are super important and they help us with that. So one thing that's important to remember is if we integrate something, so we integrate capital F prime, of course we're going to get capital F, the antiderivative of F prime, evaluated at B minus A. Well, this is going to be the net change. So important to remember that that answer certainly can be negative or zero. It's net change, okay? Now, this part that's at the bottom of the front page of your notes, and then there's also a little example there, I would strongly suggest that you take a picture or make a scan of that and actually just put that whole entire part, make a page about particle motion, and I would just put that whole thing right there, because that's a very good synopsis for you about what happens if you're given velocity. And then they're asking you about displacement, distance traveled, or actual position. This is a very, very common question on the AP test, and so it's really good for you to understand how to connect all those things. So just strong suggestion, just from 3 main question stems down, you could just scan that and make a page about particle motion, questions about velocity graphs, something like that. And then that would just be a really good thing. So first thing, of course, is displacement. So if your figure looks like the figure we have here, where we have A1, A2, and A3, we have these 3 areas. Now, of course, area is always positive, but the answer for using, for example, A2, that value underneath there is negative as far as the integral goes. So like if we look at displacement just integrates v of t, where this function that's here is the velocity. Well, it's going to be A1 positive, and then it's going to be minus A2, because A2 is still going to be, the area is going to be a number like 10. Underneath it is why we subtract it, because that's underneath the x-axis, and then plus A3, so that's displacement. So displacement could be 0, and it could definitely be negative, okay? So that's displacement. If I want the total distance traveled, then I have to do the absolute value of velocity and integrate that from A to B. And then in that case, I just add up those areas all positive, no negative signs anywhere, just A1 plus A2 plus A3. And then this is probably one of the biggest ones that gets missed, is when they ask me something, you're asked about what's the position of the item after 5 seconds. The thing that happens is we forget to include this initial condition. That's what ends up happening, because we just think, oh, I want to know how far it traveled, I just integrate 0 to 5. I mean, that's, or give me the displacement. But this initial condition is important, because particle, just because it's traveling on the x-axis doesn't mean its initial starting position is 0. So we have to always consider that. So that's one of the biggest things to pay attention to. So strongly consider putting this in your book. Now let's do an example of all 3 things with this right here. So first of all, we have an initial condition. So one thing that might be a really good idea, habit to get into, is circling that initial value so you don't forget it. And then we're supposed to find displacement, distance traveled, and the position on the interval 0 to 10. Okay, so we're going to answer all of those things. So for displacement, So displacement, we're simply going to integrate from 0 to 10 of v of t dt, because that's what this graph is, just v of t. That's what they tell us, y equals v of t. And when we integrate that, that means we just add the areas, but if it's underneath, or you could say we add or subtract the areas that are underneath, or we just consider the area underneath to be negative. So this would be 18 minus 12, which would be 6. If I want the distance traveled, okay, now I've got to integrate 0 to 10 of the absolute value of the velocity. And again, remember how important it is for you to write down what you're doing. So integral 0 to 10, absolute value of vt dt. So now it's going to keep everything with positive sign. So it's going to be 18 plus 12, which is going to be 30. And then last, we're asked for the position at 10 seconds, so after 10 seconds. Okay, so if we want the position that we're in after those 10 seconds, we have to take the initial position, which was 4. See, at time 0, the initial, that's the initial time, but the initial position was at 4. So if we run a number line, our little particle just happened to be starting at 4, not at 0. So I have to take 4 plus the integral from 0 to 10 of v of t dt, because that's the displacement. So if I started at 4, in this case, I went 18 to the right and 12 to the left. So that means my position will end up being 10. So I start at 4, I go 18 right, 12 left, my position is 10. Okay, so that's like where I am on the number line. Okay. Now, I'm going to go through this question fairly quickly because this is a review of the velocity graph. So you can certainly pause the video to think about things and so on. I'm going to go through it kind of quick and talk about all the things that we're supposed to remember to say to justify it. And remember, you justify whether it says to or not. You always justify. So basically, we're just answering each question, give the interval, give the reason. So for what intervals is the particle moving to the right? Okay, so the graph is velocity. So this is my velocity graph. I know the direction a particle's moving by the sign of the velocity. So I would say the particle is moving to the right on the interval. So I would say on 0 to 3 and 7 to 8. And very simple reason, because v of t greater than 0. And remember, try not to write out paragraphs like because the velocity is positive, just v of t is greater than 0. On what intervals is the particle slowing down? So remember that there is one and only one way for you to talk about a particle slowing down, and that is velocity and acceleration have different signs. That's it. So we will say the particle is slowing down on, and it's going to be slowing down when you have positive velocity, which means above the x-axis, but the slope is negative, so that's going to be 2 to 3. Or if you are underneath, so your velocity is negative, but the slope of the line is positive, so that would be 6 to 7. And our reason is because velocity and acceleration have opposite signs. And that's it. Now, if you struggled with these lessons, so take a little more time on this part. When is the particle stopped and changing directions? Okay, so the particle is going to be stopped whenever the velocity is 0 Now, it only is going to have changed directions there if the velocity sign changes positive to negative or vice versa. So in this case, our zeros are at t equals 3 and t equals 7. So at t equals 3 and t equals 7, because velocity equals 0 and changes signs there. Okay, so 0 stopped and then changing directions, that's where, because it's the sign changes. At what times is the acceleration 0? So the acceleration is the derivative of the velocity. So that means the slope of the line. So of course your slopes are 0 at these places. So the acceleration is 0. So acceleration, or you could say A of t, equals 0 when v of t is constant, because a constant will have a slope of 0. Therefore, so that would be 1 to 2 and 4 to 6 in my reason. Okay, so that's a review. All right, so now let's talk about a table problem where we could ask questions that would need us to use the table and to find some different things about distances and so on. So we have, again, a table that has velocity and time. And so question A says, find the distance in miles the bus travels between every interval using the trapezoid rule. So if you are a person who struggles with the trapezoid rule, you need to go through and do a whole bunch of these. I'm just going to give you an example of one of them, okay, and show you the answer, and then I'm going to fill in the table for the bottom, because we're not going to go through and do every one of these, but let's just take the one going from 20 to 25, okay? So I'm just going to do the trapezoid rule from here to here, because they want you to do every one of these to get the answer. And of course, the first one would be 0. But I'm just going to do 20 to 25, and then I'll fill it all in. So if I want to do from t equals 20 to t equals 25, I'm going to use the trapezoid rule to get that, because I'm going to use the area to estimate that value. So the area is going to be 1/2 of, now be careful here, this is another thing to be super careful about. The chart gives me miles per hour and the time is in minutes. So really important to remember that. So the width of my interval here is 5, so that's the height of my trapezoid, but it needs to be 5 over 60 because it's 5 minutes, so it's 5/60th of an hour. And then I take my y's and add them up. So 32 plus 4, because those will end up being my heights or my bases. My height was 5 over 60. So if I do that one, I get 1.5 miles. And you would do the same thing for all of these. And then that answer would go right here, because I'm integrating from 20 to 25. Answer is at 25, 1.5. So you may want to practice if you struggle with the trapezoid rule. I'm just going to write in the answers, and then you are more than welcome to practice some more of these and make sure you're getting them right. So you might just try like 55 to 60 and just do that and see what you get. Now, find the total distance the bus traveled in 60 minutes. Okay, so total distance equals, well, what did I find on the bottom row? I found the distance. So in order to find the total distance for this problem, I'm going to add up all of those values. So if you add up everything across the bottom there, you should get 17.2486 miles. Okay, so we found each little increment and found the distances between each stop. So the total distance traveled would be to add all of those up. All right, so The initial condition thing is just a reminder here, so that's what we're going to do on this example, okay? So we have an object moving in a straight line. We have an equation this time for velocity in meters per second. At t equals 5, the object's distance from the starting point was 12 meters in the positive direction. We want to write an integral expression that will compute the object's position at t equals 10 seconds. So what's important here is the position is going to be wherever I am initially plus the displacement. Okay, so my little particle is traveling along say it's the x-axis on this straight line. At 5, it's at position 12, and then it's going to move right and left and do whatever it's going to do for 5 seconds, and then I want to know what that displacement is. Where am I from 12? And then add that to 12, and that'll tell me where I am. So writing the expression is very easy. It's just 12, the initial position, plus, and then you integrate the rest of it, 5 to 10 of this. Now notice it says write the integral expression that will compute it. Okay, so in that part of the question, I don't do anything else, and that's important to pay attention to that on AP tests, because they often say set up but do not integrate, or write the expression. So don't overdo it. That's all I needed to write. That's the expression that gives me its position. Now B says now actually use the calculator and go ahead and find that. So then you're just going to literally enter that in the calculator, which I'm not going to do here, but you certainly need to practice that and make sure you can do it. Now remember, and if I was writing this down, like to show what I'm going to put in the calculator, I can say V of t here. I don't have to say the equation because they called it V of t. Now up here, technically, probably should have put that there, not V of t, but V of t also works. I mean, that's what they called V of t, so I'm putting that instead. So you can write it either way, so keep that in mind. Obviously, in the calculator, I have to actually put the function, but once you do yours in your calculator, then check and see that you get this answer, and then make sure you have some units. Okay? All right. Example 4, particles moving along the x-axis. Again, I have a velocity equation measured in meters per second. Initial position, s of 0 equals -3. I don't want to forget that. Determine the displacement of the particle on the time interval from 1 to 7. So displacement would be integral from 1 to 7 of v of t dt. Now, if this is not a calculator question, then that means I would actually have to do that integral. So I probably wouldn't have written v of t dt in that case. I probably would have gone ahead and written out what I have, but I'm just going to look up here. Ooh. I'm just going to look up here and I'm going to integrate it from there. So I have minus t squared, so that's going to be minus t cubed over 3 plus 7t squared over 2 minus 10t, and I'm integrating that from 1 to 7. So I have negative 7 cubed over 3 plus 7 cubed, because I'll have 7 times 7 squared, over 2 minus 70 minus parentheses, negative 1/3 plus 7/2 minus 10. Now, the reason I went ahead and did this is I want to remind you how we do this if I have to do it by hand. Now, if this was a free response question and it was no calculator, I'm done, right? That expression right there is my answer. Do not even try to simplify it. But if I'm on multiple choice, I've got to figure out a way to match this up. So remember that what we would want to do is add together the things that have, like denominators, okay? So I have negative 7 cubed over 3. Well, 7 cubed, if you need to go over to the side and, in your scratch area somewhere, make it a scratch area, and then just do this multiplication. So you get 343. So this is negative 343 over 3 minus a negative 1/3, so that's going to be 344 over 3. And then I'm going to combine my things that have this denominator. So I have 343 over 2 minus 7 over 2. So 343 minus 7, again, my little scratch area here, I'm going to get 16, 336. So this will be plus 336 over 2. And then negative 70 minus negative 10, that's minus 60. Now it would be much easier for me just to do this division again over in a scratch area to the left or to the right, but be sure you box it in. I prefer the right, but I just started over here. So 344 divided by 3, that's going to go in, and you're going to get oh, was that negative 343? So this should be 342. Not, sorry, I just realized that. I was like, wait, that's not coming out even. That should be 342. So you get 12 here. So that does come out even. I had negative 343 over 3 minus a negative. So this is negative 342. Sorry, I was doing my multiplication over here and I didn't pay attention that this was negative. Okay, so this is negative 342 over 3. Now when I divide, I'm going to get, I will be able to get my answer here, which is 114. So this is negative 114. And then 336 divided by 2, I should be able to do without needing to write all that out, I hope. So that's going to be 168 minus 60. So then I would combine. So I have negative 174 plus 168, negative 6. And then this is in feet because it was feet per second. And this is displacement. So in other words, it has moved negative 6 feet, which means it is 6 to the left of where it started, okay? Now, what is the total distance traveled by the particle? So now I have a little bit of work that I'm going to have to do here. So if it's a calculator question, this is very easy. I integrate from 1 to 7 of v of t absolute value dt. But by hand, I cannot do that because I have to know whether it's above or below. So going back up to this velocity equation, I've got to figure out, so I'm going to make a scratch area here. I need to figure out when is this positive and negative. So I'm going to factor out the negative, t squared minus 7t plus 10. So I factor this, I'm going to get negative of t minus 5, t minus 2. So at 2 and 5, this is changing directions, okay? So that's very important. So that means if I'm going from 1 to 7, I'm going to have to actually integrate from 1 to 2, plus integrating from 2 to 5, plus integrating from 5 to 7. Now, I just have to figure out whether I need to integrate the function itself or the absolute value of the function in those spots, because that's what makes the difference, doing absolute value. So from 1 to 2, we know that if we are to plug in 1 to this, okay, so if we plug in 1 here, we're going to have negative, negative, negative. So from 1 to 2, it's negative. So from 1 to 2, I have to do the opposite of minus t squared plus 7t minus 10 dt. Okay, and then from 2 to 5, it's going to be positive because it's a parabola that opens down, so it's pretty easy for me to tell it's going to be positive here. So I will actually integrate the function as given. And then from 5 to 7, I know it's also going to be negative, so I will do the opposite of this function. Now with a calculator, you would literally just have to enter that with using the function in there for velocity. But if I don't have one, I'd have to do all this by hand. Well, I'm not going to do all of that because I want you to practice that. So if you need that practice, don't forget we already found the antiderivative. So we already know what the antiderivative is. We have it right here. So you only have to write down the antiderivative each time from 1 to 2, 2 to 5, 5 to 7. And then you just have to take the opposite of the answer in the two that are opposite. So what you end up with is 22 over 12 plus 9 over 2 plus 26 over 3 after you absolute value everything, which is going to end up being, so here's an example where I can either simplify 22 over 12 first, but I'm just going to go ahead and make everything over 12 real quick. So that's a quick way to do it, is just write down the product in case it's easy to do in your head. So you're going to have 22 plus 54 plus 144, and then you're going to divide by 12. You're going to end up with 15 feet. So if you need a lot of practice with arithmetic, I would practice all that. If we're lucky, it's a calculator question, and we can just use the absolute value bars in the calculator, and that will be much easier. Okay, so let's take a little bit of a different type of example. Suppose you're driving behind a large bus at 66 feet per second, which is 45 miles an hour. You finally get a chance to pass them, so you step on the accelerator, and so you get this acceleration, 4 over the square root of t. Where a is measured in feet per second, well, and t is measured in seconds. I think they left the t off of there. On this paper, it's supposed to say t is measured in seconds. How fast are you going 16 seconds later when you have passed the bus? Okay, so we know that velocity, actually absolute value of velocity is going to give me my speed, right? So velocity is going to be the integral of acceleration, and I have a formula for acceleration. And so you're going to get velocity as an equation if we integrate acceleration. So I'm going to rewrite that as 4 in my scratch area over here, 4 over t to the 1/2, or 4t to the negative 1/2. So when I integrate that, I'm going to get t to the positive 1/2. So that's square root of t times 2, so that's 8. 8 square root of t plus c. If you need more help, then you just work on that on the side a little bit more. Now, that's not the answer because that's just the generic equation for velocity. I need to use my initial condition, which is that v of 0, because of this right here, v of 0 equals 66. So if I plug in 0, that means my c is just going to be 66. So I get 8 square root of t plus 66. And then the question is, how fast are you going at 16 seconds? So I want velocity at 16 seconds. And notice I can very easily show all of my work here by just using the math, okay? So if I plug in 16, square root of 16 is 4. 4 times 8 is 32. 32 plus 66, 98. And then make sure we have our units, which is feet per second. Now, how far did you travel during that time? Well, if I want to know how far I went, then I want my distance. So that would be integrating from 0 to 16 of absolute value of velocity. Well, that's going to end up being integrating 0 to 16 absolute value of velocity equation, which was 8t to the 1/2 plus 66 dt. Well, luckily this is always positive, right? Because square root of t is above 0, and then 8's positive and 66 is positive, so I don't have to worry about splitting anything here. I can just integrate it. So we're going to get t to the 3/2 and then we're going to do times 2/3, so that's going to make 16/3, and then plus 66t, going from 0 to 16. And so if we plug in, so if you plug in 16 to t, you're going to square root the t first, that's 4. 4 cubed is 64. 64 times 16 is 1,024 over 3, plus 16 times 66, which is 1,056, minus parentheses, plug in 0. I actually like you to remember that you actually checked and it is 0. And if we do this, of course, if this was a calculator problem, you would simply put this in the calculator, write the answer. If it's not one and it's a free response question, I would have just written 16 times 64 over 3, etc. Don't do much simplifying. And so for the calculator question, this is what we're going to get. Now again, if you need a lot of practice though with fractions and some of that stuff, go ahead and practice just because that's good for you. All right, what is your average velocity over the 16-second interval? So to find average velocity, we take displacement over time. That's how we find our average velocity. So that's going to be 1397.333. That was our displacement over time of 16, which is going to give us an average velocity of 87.333 feet per second. Okay. So let's go ahead and we're going to skip example 6, and we're going to look at example 7. So here we have a particle moving on this graph. This is the graph of the velocity. So this is not the position of the particle. Particle's just moving along the x-axis. Okay? And don't forget what that looks like. That's like if we just have an x-axis and then we got our little particle on there. Our little particle is just doing this. Our particle is just moving back and forth, whatever it's doing. Okay? But this is the equation or the example, the graph of the velocity. They tell you it's a differentiable function whose graph is shown here. At time t equals 0, the particle is at x equals 4. Okay, so again, like if this was a number line, maybe this x-axis has 0 here and this is 4. So we're just saying little particle starting off here. At time 0, there's particle. Okay, it's right there at position 4. Now it tells us that the velocity is 0 at t equals 3, 9, and 13. So they're just telling you that's crossing at 3, 9, and 13. There are horizontal tangents at 6 and 11. So where they look to be. So here and here you have horizontal tangents. The areas are written in. Okay, so they've written the numbers in for what the areas are. Okay, so now we're going to answer some questions. So first question, for 0 to 15, find the time and position of the particle when the particle is farthest to the right. Okay, so how are we going to figure out when it's farthest to the right? Well, let's think about what's happening. The particle is starting at 4, and then it's moving. If you integrate this, it's moving 6 to the right, okay? Then it's moving 9 to the left, and then it's moving 3 to the right, and then 2 to the left, okay? So if you wanted to, you could visualize that on a number line, okay? Like if you needed some help with that, you could think to yourself, okay, here's 0. It starts at 4. It's going to go 6 to the right. So here's your particle moving 6 to the right. Then it's going to move 9 to the left. So that's going to put it at 1. And then it's going to move 3 to the right. So it's going to be back to 4. And then it's going to move 2 to the left. So it's going to move just 2 this way. So that's going to put it at 2. Okay? So the question is, what's its position when it's farthest to the right? Well, it has to be farthest to the right. If it started at 4 and moved 6 to the right, that's going to be the farthest. Okay? So I like to kind of look at that little analyze it that way. You can also justify it by looking at different things. So position at 3, and the reason again I would choose that is because it's moving to the right. So it's going to be at 4 plus integral 0 to 3 of the velocity function, which gives me 4 plus 6, which is 10. Okay, so that's its position. Position at 13, because it moves left, but then it moves right again. So it's the only other option where it could be farther to the right. That's the initial position, integrate 0 to 13, vt dt, and then that's basically what we just drew. So it's at 4, it moves 6 right, 9 left, 3 right, and its position is now at 4. So therefore, the position is farthest to the right at t equals 3. Okay, so the particle is farthest to the right at t equals 3 seconds. Okay, so that's kind of what you're just thinking about. All right. And that's my justification, because I just showed position at 3 and position at 13, because that's the only times it was moving to the right. So therefore, that gave me the farthest it could be. And then for how many values of t is the particle equal to x equals 4? Well, so we've got to think about some things, okay, about what's going on here again with the particle. So first of all, they told us that the particles movement is continuous, and they told us that v was differentiable, which means it's continuous, okay? So it's continuously moving. Well, what we know is that we know it has to equal 4 by the intermediate value theorem. If it equals less than 4 and then greater than 4, it has to equal 4 at some point. So it has to go through that position, okay? So we know that some things that we know that can help us answer that, okay, is that we know x of 0 is 4, so that's one time. And then if we go to x of 10, or I mean, sorry, x of 3 seconds, we get 10. So we know it went, that has to be one place that it equals 4, because it was 4 at the beginning. And if we go from x of 3, which is 10, to x of 9, which was 1, we have to have another time we went through 4, because it goes 10 to 1. And then if we go x of 9, which was position 1, to x of 13, which was at 4, then again, we got a value where it was 4. And then if we go x of 13 equals 4 to x of 15 equals 2, that does not pass through 4. So we do have 3 times when it should equal 4, and that's at 0 and 13 for sure, and then somewhere between 3 seconds and 9 seconds. And basically we can just say by the intermediate value theorem, since particles movement is continuous, there are 3 places guaranteed by the intermediate, guaranteed equal 4. Okay, so I'm not going to go to write all of that out, but you get the idea. Now, a lot of times this would be on a question that's like multiple choice, and they're just like, how many times could it equal 4? And so you just have to look how many times it go back and forth across 4. Okay, so on what interval is the speed of the particle increasing? And give a reason for that answer. So again, speed increasing. In other words, when is it speeding up? Okay, that's the same thing as saying speeding up. The only way it can be speeding up is when the velocity and acceleration have the same signs. Okay, so let's go back and look at our graph. So remember that the acceleration is the derivative here. So from 0 to 3, the derivative, everywhere from 0 to 3, the derivatives are all negative. So velocity is positive, but the acceleration is negative. So from 0 to 3, it has to be slowing down. When we get down here, you have a velocity that's negative because it's underneath the x-axis, but you also have negative slopes. So that means from 3 to 6 here, you're going to have negative velocity and negative acceleration, so it has to be speeding up. If we go from 6 to 9, we see that we have positive slopes and negative velocity, so that's slowing down. If we go from 9 to 11, we have positive velocity because it's above the x-axis, and we have positive tangent lines, so that's positive derivative. So from 9 to 11 it would be, and then we would have negative slopes but positive velocity because we're above the x-axis. Here we would still have negative slopes, but we have negative velocity. So that means from 3 to 6, 9 to 11, and 13 to 15. Those would be when the particle is speeding up. Speed increasing, speeding up, same thing, okay? So it is increasing, so speed is increasing where velocity and acceleration, which I'm going to say slope of velocity, just to be very clear, have the same sign. That occurs on intervals. So your intervals would be from 3 to 6, 9 to 11, 13 to 15. I think it was just those three, is that right? Yeah, we had 3 intervals. Okay, so just remember that's how you prove that. And then during what time intervals, if any, is the acceleration of the particle positive? So again, positive acceleration, well, I just drew all those tangent lines. So anywhere the tangent lines would be positive, which means the velocity is increasing. So where this graph is increasing would be from 9 to 3, and that would be the only place that we would have the acceleration positive. So we would say that it would be positive from, oh, not 9, I think I said 9 because of that number there, that's 6, right? This is 6. So from 6 to 11, sorry, I was looking at the numbers written for the areas. So from 6 to 11, so we would say the acceleration is positive on 6 to 11 because velocity is increasing. There. Okay, so if the velocity is increasing, the acceleration is positive. All right, so that is it for this video about another look at particle motion.